So I've had this idea for a talk for a while that I figured would take like 30 or 40 minutes, but I figured what the heck, let's make it 5. In the late 1980s, the movie Max Headroom came out, and it featured Edison Carter, the news reporter, set in a dystopian near future. There's a lot of things like bad 80s haircuts and silly hairdos that I liked about this movie, but in particular, the puzzles, the rebus that you saw on the last screen. This is a talk about complexity and the limits of control, how we deal with complex systems, and the tools we build to work with those systems. I want to talk about 3 types of complexity: domain, inherent, system complexity, the software we build, and social, the organizations we use to build and run those systems. Domain complexity is the inherent capability, the inherent model of the system, like a thunderhead that you see modeled in the background here. The domain requires this level of complexity. These are non-simple things and inherent complications. How do we deal with those? So I'm going to borrow a set of metaphors from different disciplines. From controls theory, there's observability and reachability. Can we reach the target state, and can we observe the internal variables? Is the system over-constrained and under-constrained, or under-constrained? Is it over-constrained in that you can't reach the optimal solution, or under-constrained in the sense that there are multiple possible valid solutions? From chemistry, you've got model accuracy, stoichiometry, and dimensional analysis. Do the equations balance on the left and the right side? Do the dimensions even make sense? So, what do you do when you model complex systems? You use simplifying metaphors. And the spherical cow is a joke from physics. It's maybe a joke about physicists that if you abstract the complexity away too much, you come up with a useless metaphor. So, besides the domain complexity, there's software complexity. The design that we build to account for that. It's a model that's only as simple as possible. From mechanical engineering, there's similitude. So if you can build a smaller model of an aircraft, it still has to have the same fluid dynamics as the actual object itself. In a dev environment, does a clustered system have only one node? That's not similitude. From mathematics, there's state space analysis. Rather than using observable and direct variables like dimension, there's a state space of derived variables. And Richard Cook has written a lot about failure conditions. And in his state space, he uses things like economic constraints and human error when they get under stress. Social complexity is how we organize and how we deal with organizations with a bunch of beasts trying to work together and trying to, just get along. So there's this really hilarious video from Atlassian that is kind of a joke about pair programming. They call it spoon, fork, knife. You spoon, you fork the code, and you insert it back in with a knife. But it's a really delicate and hilarious joke. But in reality, in social settings, how do you deal with failure and how do you deal with errors? Some of it's semantics. Mistakes are made. As Richard Nixon said, mistakes were made. From human factors, there's a seminal work called Design of Everyday Things, a book about things like door handles that don't tell you whether you should push or pull, which I'm sure you've all, like I have, walked straight into. So, again, like 30 minutes, 40 minutes talk, but what are the commonalities here? What are the unifying abstractions that we can draw? Errors get made. There is inherent complexity. There are things we have to account for. And what's a template you can apply? You've got a rebus, the puzzle. You've got a rubric or heuristic, like your model that you would apply, and you want to come up with a simplifying metaphor. So make models, make lots of models. Let them fail fast, right? But use similitude to verify veracity and accuracy. Use simulation to verify that it even works. And use other methods like static analysis, verifiability, and that sort of thing. So that's pretty much it. I just want to try to summarize it and say that this is a template, this is a rubric, or an approach that you might apply to any problem of any sort. The last thing is, First Robotics is this amazing organization I've volunteered for a couple of years in a row now. And they have this idea of gracious professionalism, which first is about teaching kids to use robotics, but in reality it's about doing social organization. My name is Caleb Hyde. I'm an engineer, a software developer. I geek out on things like Oculus, and I'm available for hire. Thanks.
What age group is the robotics club for?
Middle school and high school. Perfect question. Yeah.
There's first Lego Robotics, which is like the elementary.
Yeah,
my son does that.
Yeah,
My son does the first stuff too. It's the new generation of it. They switched like what robots they used last year. They got a new cooler kind.
High school stuff is off the book.
And then
Like,
they go watch the high schoolers and do some
50 kids, they organize, they drum up funds all year round. I mean, it's a big deal.